Hey Algebra 1, here are the 8.2 notes for dividing monomials for day 2. Today specifically we're going to be talking about negative exponents. So a quick review of 8.1 and 8.2. To simplify things that are multiplied, we're going to add exponents. But first we have to distribute any exponents on the outside of our parentheses into them. So you have negative 4 squared x to the 6, remember we multiply those exponents, times negative 3r5x. Now I'm going to just quick simplify this. I know negative 4 times negative 4 is positive 16. Don't get tripped up by that negative. Remember, when we square a negative number, it still becomes positive. I'm then going to move this negative 3 over just so I remember that I have to multiply it at the end. Now what am I left with? I have an x6, an r5, and an x. Well, I know if my x6 is multiplied by my x, I'm going to add the exponents, and I'm going to leave the r5 alone. There's nothing it can be combined with. The only thing I have to do is simplify this last set of numbers. So 16 times negative 3 is negative 48. x7 can't be reduced, and neither can r5. I know I'm going through these pretty quick, but because it is a review, I'm not going to spend too much time on them. All right, another one of those nasty ones from yesterday with the exponent outside of a fraction. Let's start this one by just simplifying what's in parentheses. 2 over 3 can't be reduced, but p4 over p3, remember if we're dividing, we subtract their exponents. So we have p to the positive 1. q4 over q2, we subtract, becomes q to the 2, and the squared remains outside. Now we can distribute in. 2 squared, I'm not even going to write this step down, but 2 squared is 4. P to the 1 to the 2 becomes p squared, and q squared to the second becomes q to the 4. Remember, multiplying those exponents. And then we also have squared going to the bottom as well as the top. So 3 squared is not 6, it is 3 times 3, which is 9. I can't reduce any further, so that is my final answer. All right, one more, and this one's a little tricky because we could start by dividing y's and getting things that way. But I noticed that I have y's on top, and it's like combining things on either side of an equal sign. Let's combine on top and on bottom first, and then go across the fraction. I am going to reduce negative 6 over 8 to negative 3 over 4 because I know how to reduce a fraction. And then I see that y2 and y3, when I add their exponents, become y5, and y3 and y become y4. I also see that these cancel out, so I could have had y2 over y. That would have also been another way to reduce. But then when I simplify this, I get negative 3, just a single y, over 4. And that's what that looks like. So today's lesson is more specific about negative powers. But before we can understand negative powers, we also have to understand things to the 0 power. So I want you to think of it this way. 3 to the 0 power is 1. I can prove that with a calculator right now, but it doesn't make much sense as to why that's true. Well, if we think about 3 to the 1, we know that's 3. The way I like to remember this, and the way that a student put it really well, was that if you have a pizza split into 0 pieces, you still have one whole pizza. So the same thing for a negative number. If I split a negative pizza, you know, those ones with pineapple, into 0 pieces, I still have one whole pizza. Now here's where it gets a little tricky. This was in parentheses, so it said that we were taking the whole negative 3 number to the exponent of 0. But why is this one different? They look very similar, but only one of them has parentheses. Well, we have to remember what PEMDAS says. PEMDAS says I have to do the exponent first and then multiply my result by negative 1. So if I write my step out, that's going to look like this, 3 to the 0 times negative 1. And when we do that, we actually get -1 as our answer because 3 to the 0 is 1 times -1 is -1 overall. But notice this only happens one time because our pattern continues with variables. Anything to the 0 that is not a negative, it doesn't cause any problems, still becomes a 1. So now let's start to talk a little bit more about those negative exponents that I've been chattering about. Negative exponents start out on the top, but the way that I like to remember them is that they're not happy where they're at. So in order to make them happy, I'm going to take the entire term and I'm going to move it to the bottom where it is happy. But when I do that, I also have to flip this one up as a placeholder. So this becomes 1, because there's nothing up there anymore, over 3 to the 2. Notice, when I flip it down to the bottom, the negative goes away because it's happier to be on the bottom. In order to simplify this, I do have to take 3 squared so that my final answer becomes 1 over 9. Let's see that again. In this problem, we have -3 to the -2. Again, that starts out on the top, but it's not happy where it's at, so we move it to the bottom of the fraction. In doing that, we have 1 over -3 squared. But just as I did last time, when I simplify that denominator, I get -3 times -3, or 1 over 9. Now, how is it possible that one of these started with a positive number and one of them started with a negative number, but I ended with the same answer? Well, here's the thing. Exponents are tricky. Even though these are different, when you multiply them, the negative goes away. Remember, a positive times a positive is a positive, and a negative times a negative is a positive. So exponents turn things positive. All right, let's see it again. Just like we had a little bit of trickery up here, there's a little bit of trickery with this problem. Remember, we start out with -3 to the -2. We take the whole term and flip it to the bottom, and it becomes 1 over -3 to the 2. But because there's no parentheses, I have to do PEMDAS, and I have to take my exponent, then multiply by that negative. So when I simplify, this becomes 1 over 3 squared is 9. 9 times -1 is -9. The same way that this one became negative, so does that one. All right, let's look at one last negative here. We have 1/3 to the -2. Now this one, just like I was doing with my review problems from yesterday, where I had to distribute the 2 into them, I have to do the same thing with this number. I have to distribute in as 1 to the -2 over 3 to the -2. To simplify this now, I have to flip both of them. The 1 goes to the bottom, and, believe it or not, the 3 goes to the top. The same way that a negative exponent on top will flip a number to the bottom, a negative exponent on bottom will flip it to the top. So this becomes 3 squared over 1 squared. And when I simplify that, it just becomes 9 over 1, or 9. So you can see how some of these problems, even though they're very similar, have really small differences. So let's look at this final problem. How can I rewrite x to the -3 with a positive exponent? Well, if I flip x to the bottom, I can write it as 1 over x to the 3rd. And just like I was doing before, how do we simplify something like this? Well, let's bring it down and look here. We have a to the -3 times d over b to the -2 times c. Now, if I simplify this, I need to flip the a down and the b up. So I'm going to do that. I'm going to leave the d alone because it doesn't have a negative exponent. It has a 1, so I'm going to leave that. But when I flip it, the a to the third goes to the bottom, and the b squared goes to the top, and then the d and the c are left alone. Now notice there's no more negative exponents, there's nothing else I can combine or reduce, so I am done. And then one last big main idea. We are only finished simplifying these when we have no more negative exponents. So I'm going to highlight this to remind myself. All right, if you have any questions, let me know.